Hello and welcome to an explanation of Irving's stable roommate matching algorithm. The algorithm does what it says on the tin. It looks to match up pairs of individuals in a stable way. But what is a stable matching? A stable matching is one where no two individuals prefer each other over their current match. For example, if A and B are matched up and C and D are matched up, this is unstable because B prefers C over its current match A, and also C prefers B over its current match D, and also B and C aren't matched up, therefore making it unstable. Hopefully this will become more clear as we work through this example.
So this algorithm works in three phases. The first phase is the initial matching of the individuals to their preferred individuals. So A would propose to B, and if at any case it gets rejected, A would then move to F in the order of preference. Phase 2 then looks at the proposal that's already been accepted, and if the proposal that's accepted has any matches that are less preferred in it, then the individual will reject those that are less preferred than his current match. This then moves on to phase 3, which looks to see if any individuals have more than one possible match left. If they have more than one possible match, the algorithm searches for cycles and rejects as appropriate to make sure everyone is stably matched and they only have one possible match at the end.
We'll explain more about how it does this later on.
Now, we will move into phase 1 of the algorithm. So A proposes to B, who accepts because B has not been proposed to. B proposes to C, who accepts. C proposes to E, also accepts. Now D proposes to C, but C has already been proposed to by B. Now we look in C, and it's B is preferred over D. So C rejects D, and D rejects C because this match is no longer possible, and D now has to move to its next preference, B. B has been proposed to by A, who it rejects because it prefers D over A.
So B accepts D and rejects A. Lots of squeaking.
Yep. Now A is not matched, so A now has to propose to F, who accepts. E proposes to A, who accepts.
A is also not been proposed to, despite A doing proposing earlier.
F proposes to C. C rejects F because it prefers B over F. And so F rejects C also. F proposes to A, who accepts. Because F is preferred over E by A. So A rejects E, and F is accepted. E proposes to D, who accepts because D has not been proposed to.
Right, as you can see, this column is now full of unique values, so A, B, C, D, E, and F. So now we move to phase 2, whereby we look to reject all matches that can no longer happen. So in F, we look to see who F prefers less than A, who is E, B, and D here. So F will now reject
E, and E rejects F. F rejects B, and B rejects F. And F rejects D, and D rejects F also.
Wonderful. So now we look at the next match. So we look in C to see who C prefers less than B, which is nobody who hasn't already been rejected. Now we look in E to see any possible matches that are worth less than C, who is nobody. Now we look in B to see who B prefers less than D, again nobody. In D, below E, nobody. In A, below F, there are people here.
C is rejected by A, and A rejects C.
And also D.
And A rejects D, and D rejects A.
Okay, so now that's phase 2 done. We move on to phase 3.
Phase 3 now looks for individuals that have more than one possible match. So here you can see it's B, C, D, and E. So B becomes PI, or the first P. And now Q is from the second preference of B, which is E. E's final preference becomes PI plus 1, which is C. C's second preference is B, whose least preference is D, whose second preference is E, and we know E's least preferable is C. So
Right.
this is a cycle.
This is a cycle, so we can see a value twice in the sign of P. So
From the first value of Q, E rejects C, which means C rejects E,
let me just go down my side.
and B rejects D,
B also, yep.
which means D rejects B,
Okay. This is now done with. Can I borrow the rug, please? Thank you. So now we look for any more cycles.
There's another cycle where B and E still have two
So-
possible matches.
Okay, so we go for B again, that's fine.
Second preference E.
Yep.
Least preferred is B.
B again, okay, that's a cycle straight away.
So E rejects B, B rejects E, and now each of the individuals only has one possible match,
So phase 3 is done.
which means the algorithm is completed, and A is matched with F, B is matched with C,
Yep.
and D is happily matched with E.
Wonderful, that's the algorithm over. So this algorithm takes order of n squared time, according to Irving. If you want to see how it does that, that's in Irving's paper, linked in the description down below.
The pseudocode is also in the description below if you are interested in seeing the pseudocode. Thank you for watching our video.
Have a nice
Have
day.
fun algorithming.
God, yeah.